So here's what we got. Are you starting? Mm-hmm. Right. So we're going to move on to protons, neutrons, and electrons. I'm hoping some people went through and you can review these. So what's the main pieces of information we need to know about the proton? Somebody.
Oh, it's positive.
Okay, so it is a part of an atom that is positive. What else? There's a couple other things. There's two other pieces of information I want you to know about the proton. It's positive, I got it. What else do we need to know about it?
Isn't it like the same amount as neutrons?
No, it's not the same amount of neutrons. It's found where?
Nucleus.
Inside the nucleus. Found inside the nucleus. And it has a mass. And that mass equals 0.000000000001. That sounds like a small number. 0.0000000001 is going to be hard to write. Because who wants to write 0.0000000001 every time they talk about the mass of a proton, which is 0.0000000001? So instead of writing 0.0000000001 every time they talk about the mass of a proton, which is 0.0000000001, scientists have created a shorthand way of writing the mass of a proton, which is 0.0000000001. Instead of writing 0.0000000001 every time that they wrote the mass of a proton, which happens to be 0.0000000001, because who wants to write 0.0000000001 every time they...
There's 11!
There's supposed to be 11. I don't know if I actually counted it. That's what I remember the number to be, but it's a small number. Another way, so what I'm trying to get at is one, annoy you, and it works. And I always do it because everybody gets annoyed, and then I do it a few more times just to keep beating the dead horse. And everybody gets annoyed at a different point. Some people get annoyed after like the second one. Some people have to, it has to be like the 10th or 11th one, like when's he gonna stop? But anyway, so the mass, they've created a way to make the shorthand. Instead of writing the mass of the proton, which is extremely small, they call it one atomic mass unit. Why is it called atomic mass unit? Because that's what makes up the atomic mass, or part of what makes up the atomic mass. So the mass of a proton is called 1 AMU. So if you're looking at the atomic mass down here, it's 14.007 atomic mass units. So all the periodic tables masses are atomic mass units. They're these protons that have been changed instead of writing the long hand way of writing it. So protons have a mass. They're found inside the nucleus. They have a positive charge. And then I'll put a fourth piece of information because some that made you remember I want to write it, is always equal to atomic number. This one never changes. It is always equal to the atomic number. Now, with that being said, what should I know about Jimmy? What should I know about Jimmy Neutron? Okay, so it's the part of an atom that is neutral. It is not negative, it is neutral, which means it has no charge whatsoever, and it'll come into play when we start talking about the types and the parts. Where can I find a neutron?
Inside the nucleus.
I find it inside the nucleus, so it's found inside the nucleus. That's important to understand. If it's found inside of the nucleus, does it have a mass?
Yes.
The correct answer is yes. Also, how do I know that it has a mass? What it's included in my calculation of the mass number that's on the periodic chart. It's the protons plus my number of neutrons. So it has a mass. And that mass will equal 0.00000000001. Instead of writing 0.00000000001, every time they write the mass of a neutron, which is 0.000000001, because 0.000000001 is, I know, I don't count them out in my head. So, my point being, same mass as a proton. Since it has the same mass as a proton, what do you think that the scientists are going to change it to? What's going to be the mass of a neutron? How many AMU? A single neutron has a mass of 1 atomic mass unit. So if you have 2, how many atomic mass units do you have? 2 AMU, right? If you have 1 proton and 1 neutron, what's your atomic mass unit? What's your atomic mass? If you have 1 proton and 1 neutron, what's your atomic mass, Summit? 2, because we add protons plus neutrons. All right? Next. What we got? We got an electron.
Negative charge.
Okay, so it's part of an atom. With a negative.
Found outside
Woo! Found. Round the outside, round the outside, round the outside. Guess who's back? Back again. Shady's back. So they're found round the outside, round the outside, round the outside. 2 trailer park roads go round the outside. No?
Yeah.
So they're found outside, and my outside was really written really weird. Now,
Oh my God.
does an electron take up space?
Yeah.
Yes. So an electron takes up space. So an electron, would it, if we could rip it off, would it have a mass?
No.
Yes, it would. The mass of an electron is 0.0000000000000000000000000000001.
Oh, there's more zeros.
If I'm not mistaken, I haven't looked up and checked it, but the number that sticks out of my head is 10 to the negative 34.
Okay.
So there's 34 exponents. It's 34 zeros in front, decimal point 34 zeros. The way that I like to explain it is, Tim, if you had a $1 billion
Oh.
and there was a penny in your pocket,
Okay.
does that penny really matter to the amount of money that you have in the bank?
It does.
No. It does to me.
Every penny counts.
Do you know how many pennies?
If you have $1 billion in the bank,
Yes.
1 penny is going to matter?
Yes, because after amount of time in the bank, since you have $1 million, that extra penny, it's going to build up, right? Yeah.
Right. Just go with this.
No, I know. I do think about that. But you have so much money
Oh,
that penny means absolutely. That penny should mean absolutely nothing.
Oh, okay. I'll tell you.
1 penny should mean nothing.
Well, you know,
Let's put it this way: if you have if you have 999,999,999.99, would you tell somebody that you had 999,000, or you say I basically have $1 billion?
I would pick up a penny.
Well, I'm trying to say I have $1 billion.
Right, you say you have $1 billion because that 1 penny means nothing,
Yeah.
right?
Unless you want to be like, oh, I have $1 billion and 1 penny.
Right. And who would say that?
That's
Who would say that? I have $1 billion in 1 penny.
Dude, that would be me.
Because he's so big.
Hey, I'm not stupid much for it.
So Solomon got past what I was trying to get at. So, do electrons have a mass?
No.
No, because their mass is, they have a mass, but their mass is so much smaller that it would take almost 1 million electrons to make 1 atomic mass unit, or to make any difference. So they have a mass, but that mass is so small it doesn't matter. So they have no mass. So we do not add them into their mass. They have a mass, but the mass is so small that we can basically say they don't have a mass. So now, we have to take my periodic table, my protons, neutrons, and electrons, and we got to draw out what an atom looks like.
Okay.
So, first thing I want to do, off on the side, we're going to draw out nitrogen. Nitrogen is my atom, and we're going to start drawing it out. We're going to translate that box into an image of what the atom looks like. So we have neutron. The information that I need is the atomic number. I need my atomic mass. I need protons. I need electrons. And I need neutrons. Before I can draw anything out. How do I find all of this information? How do I find my number of protons? Periodic table. How do I find electrons? Periodic table in the definition of this. How do I find neutrons? Periodic table. So I have to use everything that we just talked about to find this information. So I want to do this one by myself. We'll do a second one together. So as I'm doing this, take notes. I'll talk my way through it.
But where is the electron in the period?
Say that again.
The electron in the
There, it's basically based upon this definition, and I'll talk my way through. Because for what we're talking about now, the charge has to be 0. So my negative charge must equal my positive charge.
So the protons, I mean, is the same as the...
For today, but yes. As we're doing this simple to get understanding of what atoms look like, yes.
That's what I was saying.
Yes.
Protons equal to electrons.
Atomic number. What's the atomic number for nitrogen? Well, if I go to my periodic table, my atomic number is 7. My atomic mass is what? According to the periodic table, it says 14.007. But I need a whole number. So I have to round. If I'm rounding, I look at that first number to the right of the decimal point. It is a 0. So what is my nearest whole number? 14. Now, protons. I know from my definition of a proton that it's always equal to the atomic number. So my number of protons must equal 7. So I'm going to draw this out, and this may help some people and may not help people. I have 1, 2, 3, 4, 5, 6, 7. I have 7 positives. I must negate, I must cancel out each one of those positives. Which part of my atom will carry the negative charge to knock out those charges? The electrons. So if I have 1 electron, that's 1 charge. 2, 3, 4, 5, 6, 7. So how many electrons will I need? I need 7 electrons. Because electrons have a positive, protons have a plus. Unless this atom says that it's charged, we have to make the number of protons equal the number of electrons. And atoms can become charged. Now, here's where the one that comes the problem. How do I find my number of neutrons? It's a math problem. It's the atomic mass
Minus the proton.
minus the number of protons.
Which is 7.
So let's do the math problem, right? So it's atomic mass. What do I substitute in for atomic mass? 14 minus number of protons. 7 gives me 7. Huh, winner, 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 chicken dinner.
7. Is that what you like to say?
It's the James Bond of elements, and it gets me winning on my slot machines.
Whoa.
777, 21. Blackjack, slot machines, 21. Anyway. Any questions, honestly? Any questions about where I got this information from? Any questions here? Alright, so now. Donut.
Donuts. You sound like
Donut.
You gotta put some.
So what do we call this little center circle? That center circle is called the nucleus. What is inside of my nucleus? Colby.
Oh, sorry.
Or, sorry, Cole. What is inside of my nucleus? Protons and neutrons. So what numbers will I write in my nucleus?
7 and 7.
I'll write a 7 and a 7. This is the outside portion for what we're drawing out right now. I'm just going to put all the electrons on one level, and we're going to call them electrons. How many electrons go around the outside? Around the outside.
7, Matt. 7.
So I want you guys to draw out, very similar to what we just did right here. We did nitrogen on the board because it's my favorite. I would like you to draw out one that's highly important to all living things. Carbon.
Carbon.
So do carbon. Cut. Cut.